Hello, this is a walkthrough video for assignment pc6.3, which are some IXLs. And of course, you remember that IXL has its own built-in help features, right? But I'll give you a little walkthrough, get you going, and we'll see what's what with that. So here we go. All right, so M.6, 7, 8, and 9. All right, so we got to go get M, which is going to be, we're going into pre-calculus. And then we're going to go to M. There's M, 6, 7, 8, and 9. Oh, more trigonometric ratios using the unit circle. So let's just, I'm sure we're going to need one. So let's go get a unit circle. Very, very difficult to find. Just Google unit circle and click images. Of course, there's videos about them if you want them too. You know what I'm going to do? I'm going to make sure I get a large one because I don't really like them to be all fuzzy for me. So what one looks good? There's one from UCF. We'll do that one. And we're going to click open image in new tab. So there's our unit circle. Oh, that's nice and sharp and wonderful. Okay, so here we go. M6, find trigonometric ratios using the unit circle. We'll do a couple of these. The terminal side, okay, so there's a little bit of a language thing here, right? The terminal side of an angle, theta, stands in standard position and intersects the unit circle at 4/5, 3/5. What is the cosine of theta? Okay, so let's just walk through this. There's just a couple things to walk through real briefly. Okay, so an angle in standard position, that means that it's on the coordinate plane with the beginning of it in the 0, 0 position. So if it's in standard position, that means whatever line you're drawing starts there, and the terminal side of it intersects the unit circle. So we'll just do a little unit circle action here. Let's call that our unit circle. I'm not sure where 3 and 4, 3/5, 4/5, where they actually land, but who cares? We don't care. Intersects the unit circle at 4/5, 3/5. So first of all, we notice those are both plus, right? Which means that it's going to be in quadrant 1, right? Because quadrant 1 is plus, comma, plus. All the coordinates in comma 1 are plus, comma, plus. All the coordinates in quadrant 2 are going to be negative x, positive y. All the coordinates in sector 3 are going to be negative, comma, negative. So it should be parentheses. And then in quadrant 4 are going to be a positive x value and a negative y value, which also means it's going to have a positive cosine and a negative sine, right? Okay, so these are, it intersects a unit circle at 4/5, 3/5. So 4/5, it's going to be like somewhere there, who knows, right? Something like that, but who cares exactly where? And so we're looking for the, when I actually give you the answer, it's going to be you're going to be like, why'd you take all that time to do that? Okay, so we know it intersects the unit circle, right? So if it intersects the unit circle at that point, so the unit circle means the hypotenuse of a triangle you draw like this is going to be 1, right? Because that's the whole point of the unit circle, is the radius is 1. So if you use the x and y coordinates of any point on the unit circle, you can make a right triangle with the x and the y coordinates, and the hypotenuse will be 1, which greatly simplifies the idea of finding sine and cosine, right? So this intersects the unit circle at 4/5, that's the x coordinate, so that's down 4/5 is the x coordinate, and 3/5 is the y coordinate, right? So if you're on the unit circle, because the hypotenuse is 1, sine is the opposite over hypotenuse, and cosine is the adjacent over the hypotenuse. And those are both going to be over 1. So if you have coordinates on the unit circle, the coordinates are simply cosine, comma, sine of the angle. And that's a little good review for you right there. So it's asking about the terminal side of an angle theta in standard position intersects the unit circle at that point. What is the cosine? So the cosine, after all I told you, the cosine is just that right there. And put that in there, we'll do that. And then we'll go 4 and 5 and click submit. And there we go. Brilliant. Okay. So let's see. What should we should erase some stuff here. We'll erase all this kind of stuff right there. And I guess I didn't really need to erase all that, but we definitely do need to erase that. Okay. Wow, it erased some other stuff that I didn't want it to erase. Whatever, who cares? The terminal side of an angle in standard position intersects the unit circle at 12 over 37, 35 over 37. So what is cosine theta? Well, after all we went through, you know that if something is in standard position and it intersects the unit circle at that point, then you know the coordinates are cosine, comma, sine, right? That's what you know. And so that's the answer right there. 12 over 37. 12 over 37. And that's kind of how that goes, right? So you know that you can always get, if you get one wrong, you can get help, right? So this one, the terminal side of the angle, standard position, blah, blah, blah. These are both positive, right? So you know it's in quadrant 1. But whatever those are, that's what it's going to be. So if it was negative 15 over 17, so the sine is the second one. So the answer to this one's going to be 8 over 17. If this said 15 over 17 and then it had a negative right there, so that the x would be positive and the y would be negative, that would put it down here in quadrant, well, I should have put that on the line. That would have put it down somewhere down there in quadrant 4. And all you would still do is they would say, what's the sign of that? And you would enter that coordinate, and that's all you do there. All right? So that's what's that? That's M.6. All right. Now we'll go back and see if we can get M.7. Hopefully we can do this without fine trigonometric ratios of special angles. Okay. So now we're gonna we didn't even need the unit circle for that, did we? Okay. So now we will probably need our unit circle, and that's okay because we have our unit circle. Evaluate. Write your answer in simplified, rationalized form. So rationalize, that means no radical in the denominator. All right, no radical in the denominator. Now that's going to be the rule sometimes. It won't be the rule other times. It's kind of generally the rule, so I would follow it. But so here we go. All right, the tangent of 45. Let's write SOHCAHTOA because you can never write that too many times. SOHCA, oops, I didn't write it correctly. That's a TOA right there, right? So the tangent, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Tangent equals opposite over adjacent. The opposite is going to be the y coordinate on the unit circle, right? Anyway, the opposite's going to be if you're on a grid or whatever. So that's going to be if you have x comma y, a point for an angle in standard position, then opposite, that's the y coordinate, and the adjacent, that's the x coordinate, right? So we want the tangent of 45 degrees. So we got to go to we got to look at the unit circle and we got to find out what the coordinates of 45 degrees are on the unit circle. That's really weird. Look at what did that x. So what are the coordinates of 45 degrees? We're going to go like this, and you might already know it anyways, but it says the coordinates of 45 degrees are square root of 2 over 2 and square root of 2 over 2. This particular unit circle is already rationalized for us. That's nice. So the coordinates are square root of 2 over 2. Oops. I don't think there's an undo on this. Well, that's quite horrible, isn't it? That works. Square root of 2 over 2, comma, square root of 2 over 2. Those are the coordinates. The tangent is the opposite over the adjacent. They're both exactly the same, right? So I'm going to write it out, but you probably already see where this is going. The opposite over the adjacent. And you can see you have the same on the top and the bottom, so that just equals 1. But just to kind of go through the process a tiny bit, if you have fractions on fractions, the first thing you have to do is get the numerator and the denominator each into a single fraction. And then you have to get common denominators in the fraction that's in the numerator and the fraction that's in the denominator. Because once you have common denominators in the fraction in the numerator and the fraction in the denominator, they cancel out. So these two are going to cancel each other out, which is just going to leave us with square root of 2 over 2, which of course is just 1. So 1 is the answer to the tangent of 45 degrees, which is pretty good. Makes it easy, right? Excellent. I love seeing excellence. All right, erase all that and onward. Evaluate, write your answer in simplified, rationalized form, do not round. What's the cosine of 60 degrees? So remember, if we're on the unit circle, we're going to have a coordinate on the unit circle, which is going to be x, y, and that's just going to be the cosine, comma, the sine of the angle. Why? Because the hypotenuse is 1 on the unit circle, right? And cosine and sine are both, they're either adjacent or opposite over the hypotenuse, and the hypotenuse is 1 on the unit circle. So for cosine of 60, all we're going to go do is look for the x component, the x coordinate of the point where the 60-degree line intersects the unit circle. So there's our 60-degree line, intersects the unit circle. The x coordinate is 1/2. So the cosine of 60 degrees is 1/2. 1 over 2. Okay, we'll do one more here and then we'll move on because I want to get this done before my lunch is over. Tangent of 60 degrees. Remember, we'll write SOHCAHTOA again because you can never write it too much. Tangent is opposite over adjacent. Tangent equals opposite over adjacent. The opposite is on the unit circle is the y coordinate. The adjacent is the x coordinate because that's the one on the inside, right? So if you got a triangle, I'm just trying to keep reviewing this over and over again. If you have a triangle on the unit circle, that's the x, that's the y, that's the point at which, and that's going to be 1, right? And that the coordinates of that point are, because that's 1, the coordinates of that point are going to be the lengths. Well, that's not because that's 1. Anyway, the coordinates of that point are going to be the lengths of the x and the y legs of this right triangle, right? So the tangent of 60 is going to be what? The y over the x, right? So let's just go look. There's 60 degrees again. Now we have y over x. So it's going to be, that's our y, right? And that's our x. So it's going to be square root of 3 over 2 over 1/2, right? So it's going to be square root of 3 over 2 over 1/2. So now we got fractions of fractions, right? So the first thing we remember is, now we already have what we have to do is get, if we don't already have them, we have to have a single fraction on the top and a single fraction on the bottom. And then we have to get a common denominator there. And once we have a common denominator on the upper fraction and the lower fraction, those disappear. And then we end up with square root of 3 over 1. And 1 on the bottom is just 1. So our answer is actually going to be square root of 3. Oops. I don't want to lose points, man. Set me back, right? Okay, so we'll do this one and then we'll move on. This is good, we got this one. So pi over 6. Now when you see pi, you should immediately be thinking radians, right? From the unit circle. Where is pi over 6 radians? Well, let's just think through this for a moment, real quick. So this is pi radians, right? 180, 2 pi r, that's the circumference of a circle, 2 pi radians. So it's going to be pi over 2. And 1/2 of pi over 2, that's going to be pi over 4, right? And if you divide, if you're dividing it into fourths, that's going to be pi over 4. This is also going to be the same as 2 pi over 4, and this is going to be 3 pi over 4, right? So, but if we're dividing into sixths, this is going to be pi over 6. 2 pi over 6, and then the pi over 2 is going to be 3 pi over 6. You can see that's the same fraction. So it's asking us about pi over 6. So that's 30 degrees. Pi over 4 is 45. 2 pi over 6, that's the same, that's also going to be pi over 3. That's going to be 60 degrees. But we're looking for 30 degrees. That's the same thing as pi over 6. So let's go over there and take a look. What's it asking us? Tangent. So tangent, let's just remember what we're looking for. Let's write SOHCAHTOA. SOHCAHTOA. So the tangent is the opposite over the adjacent. So that's going to be the y coordinate over the x coordinate. So we're going to go look at 30 degrees, pi over 6, and get the opposite and the adjacent coordinate on the unit circle. So it's the opposite is 1/2 and the adjacent is square root of 3 over 2. So we are going to have to actually do some math on this. So the opposite, 1/2 over square root of 3 over 2. All right, so here we go. I'm going to erase all this stuff because we might need a tiny bit of room here. All right, so tangent equals opposite over the adjacent equals y over x. And the coordinates of pi over 6 is, what was it? It was square root of 3 over 2, square root of 3 over 2, comma 1/2, right? Double check, never hurts to double check, square root of 3 over 2 over 1/2. And if the tangent, so the tangent of pi over 6 is going to equal the y over the x. So it's going to equal 1/2 over square root of 3 over 2. So we can immediately see it. We've kind of been handed a solution because we have common denominators in the fraction, the upper fraction and the lower fraction, we can call them that, have common denominators, right? So those are going to cancel out. And now we are left with 1 over the square root of 3 over the square root of 3, right? So that is an illegal answer if they want it in rationalized form. Can't leave that square root of 3 on the bottom. So what are you going to do? Well, this takes you back to, I don't know, whenever you learn all these theorems that we wonder what their use they are. It's multiply anything by 1 is itself, right? So we're going to look for a form of 1 that will manipulate the form of this equation into something that looks like what we want. And the form of 1 we're going to use is square root of 3 over 3, square root of 3 over square root of 3. That's just 1, right? Anything times 1 equals itself seemed like a stupid theorem when it seemed ridiculous when we learned it, but actually there's an awful lot of math that is just figuring out what form of 1 to multiply by, including this. Square root of 3 times square root of 3 is what? 3. Square root of 3 times 1 is square root of 3. So that's the actual answer right there. And let me see, how am I doing on time? Oh, holy cats, I'm going to run out of time. Darn it. Anyway, that's the answer. That's M7. Let's get to M8. M8, find trigonometric ratios using reference angles. So write your answer in simplified rationalized form, don't round. Cosine of 45, so this is going to be kind of the same thing, right? What's the cosine of 45? It's 1/2. Is that going to take it? Oh, no, it's not. Duh. Okay. Anyway, I'm trying to work too fast because I know some people had some problem. Secant. Okay, so the thing you got to remember here, it's the same thing. You just got to remember you got sine, you got cosine, and you got tangent. And then you got cosecant equals 1 over sine. Secant equals 1 over cosine. And tangent, cotangent, equals 1 over tangent. So if the sine is opposite over hypotenuse, secant is hypotenuse over opposite. If cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. If tangent is opposite over adjacent, then cotangent is adjacent over opposite. And that should get you through that one. And now we're going to go back and see if I can get enough here to get at least a moment or two. It was M.9 was the last one. Inverses trigonometric functions. Okay, so let's see what we got here. That is, okay, so now, oh, actually, so this is fine. This works good. All you're doing is, if the cosine of the angle is square root of 2 over 2, you just have to go find the angle, right? And so, so remember, it's cosine, it's cosine, comma, sine on the unit circle, right? And so you're looking for the angle that has the cosine square root of 2 over 2. Where's the cosine square root of 2 over 2? It's right there. So the angle is 45 degrees, right? And we'll try and do one more, and then that's going to be it. Incomplete answer? What do you mean? Find the value of, oh, I must have double clicked or something. Okay, so cosecant equals 2. So let's just do this real quick in about a minute here. So we've got sine equals the opposite over the hypotenuse, and cosecant equals the hypotenuse over the opposite, right? So the cosecant of theta equals 1. So this is going to, the hypotenuse is always 1, right? So we need to find out what, so what's the opposite going to have to be if we're going to make it equal to 2? It's going to have to be 1/2. So that's what we got to find out, is so that the, it's adjacent, comma, opposite, right? So we need to find the angle where the opposite is 1/2. And the opposite is 1/2 right there, right? Because that's square root of 3 over 2 and 1/2. So that's where the opposite is. So the angle we're looking for is 30 degrees. And hopefully that's enough, because I am plumb out of time. There's people waiting at the door. All right, so hopefully that's enough. And I'm going to end this. Take care. Bye-bye.